Today, inshallah, we're going to continue on the networking basics. Basically, last time we talked about the routers and talked about domain controllers. Today, we're going to start on servers. Servers basically play a crucial role in client-server computing environment. Basically, we said that client-server is one of the configurations of PACs, as we discussed before. And basically, it's actually not just for PACs. It has so many different applications. But let's discuss some of the functionalities of servers. What can we use servers for? Okay. For example, sometimes servers provide print services, meaning that multiple users can share printers across the network. This is actually a very good thing because basically you can get a very high quality printer and make it shared by everybody on the network rather than buying a printer for everybody, for each person or each computer. This is much more economical and much faster usually. The quality is higher. Usually this is much more efficient for an office, for example. Okay, if you have, for example, a company, it's better to have a central printer that is connected to the network, and you have a printer server so that it actually receives all the printing requests and handles them over the printer. Basically, just handles the printer centrally from that server. Okay, so this is actually is a very good thing. Okay, we're going to discuss the functionalities. I'm going to basically say how these things can be done. You can also have file services, meaning that the ability to share user-created files by storing them in a central location rather than locally. Okay, this is also very important because if you have a large company, you need to have backups of each one of the users in a central location so that it can be protected, or basically it can basically serve when a problem happens or the computer gets corrupted or infected or whatever. You can restore a backup copy from the storage location, the central storage location in the office. Okay, so these are very important basically. So basically, you have a server somewhere with storage capacity that is accessible by users. Each one of them can store his or her files in that server, and basically you can also assign different permissions. You can actually have basically these files basically either private for each user or public for the whole company, or you can actually assign access levels depending on the importance of the data. But you can have file services, you can have a large storage that is central in the organization, and basically everybody can access that. An example of the file services is what we have in the PACS archive server, okay, where we store the images, we store the studies, basically whatever comes out of the imaging equipment, basically we have to store them as files in a central location. This is the archive server. This is a very good example of file services. Okay, so this is very good actually because you conserve storage space as well as prevent different versions of the same file circulating. Sometimes you can actually use that, for example, if you have certain forms or if you have certain documentation requirements for a certain, if you have like FDA requirements or whatever for a hospital or for a company, you can actually, sometimes you have a certain form that you have to fill out whenever you do one of the tasks that you do in your job. Sometimes this form gets changed and you have multiple versions of the same document, and this is not allowed basically. You have to use the latest version of each document so that you can have the proper documentation. So basically you can actually store these documents in a central location, and whenever a person needs to access that or get a copy of that to fill it out, you can get the latest copy all the time. Okay, you don't have the problem with that. Also, if you have certain regulations or you need to have policies, updated policies, you can actually put them in a central location so that everyone can access them without any problems. So this is really important. You can have also application services, basically meaning that you can actually run processes or software programs on a server rather than on your local computer. This is actually a very good thing also, because sometimes imagine that you need to have an image viewer running on a local computer, okay? Then for an image viewer to handle 3D visualization requirements, for example, this would basically require that you have a very high-end computer. You need to buy an expensive machine for the computer to do this task, basically. But if you have a central location, or you have a server that has the required processing power, and you access the services, you access that application, that image viewer, or the 3D visualization software from that server, basically you can do it for any computer. You don't have any particular requirements in that computer to be able to just run that process on the server and just get the results and display them. All you have to do is to have a good monitor, and that's it. So this is actually very useful as well, okay? Usually if you have an environment where the processing can be done in different computers, on many computers, basically a large number of computers, but they do not happen at the same time. The processing doesn't happen at the same time. Then it's better to have the application services or the processing power in a central server, and basically each one of these computers might not need to be a high-end machine or a top-of-the-line machine. You can actually have a modest computer, and basically through that modest computer, you access that application through the network from the server, and basically the server will handle all the processing. So this is actually one of the very useful things that you can use also for reading workstations. And sometimes you have also communication services. Sometimes, as we have here at King Abdulaziz University, we don't have phone lines. We basically have what's called voice over IP, Voip. Okay, this is basically telephony over internet. Okay, so basically you need to have a server for that, and this server is connected to the phone lines. And what you do here through that server is you connect all the telephones in King Abdulaziz University to that central server through the internet, and basically it handles the conversion of the message or the calls from internet to regular phone lines. You can also have an email server. Usually you have an email server as long as you have, for example, a KEU account. There must be an email server somewhere. This email server has basically all your messages and everybody's messages, but actually now sometimes you, instead of having that email server local in the organization, people now get some services from Google. Okay, so now I think King Abdulaziz University has a contract with Google to use their servers for the email. So basically, whenever you do that, you're actually having you don't have a local server for email, but you actually contracted a global server or outsourced a global server for email that you can use from anywhere. So basically, communication services are also examples of utilities of servers in a computing environment, in an organization. Okay? So basically, these functions can be done in a variety of ways. Okay, you can have a dedicated server for each one of these, or you can have all of them in one server, basically, that handles all of them. But usually, it depends on the kind of organization you have. For example, if you're working with PACS, then you have a different server for the archive server. Okay, you have an archive server that is a little bit different from all the other ones. It's different from the print services and for application services. You have one that is dedicated just for archiving. Okay, so basically it depends on the load that you have on that server, and basically, in principle, you can have all of them in the same computer. But actually, sometimes it's very difficult to do that because you have a lot of loading on one of these services. And basically, you don't want file services, for example, to delay print services or application services or anything like that. Okay, but in principle, you can have a separate server for each one of them. Okay, the design is depending on the loading needed for each one of these. If you have any question, please interrupt at any time. Okay. For the load balancing, basically, we just mentioned that we have a problem with how we have loading in each one of these services, okay? So basically you have to somehow, if a server is loaded, for example, in the packs, we mentioned that you have a problem with networking. Basically, the archive server handles all the requests, basically. It handles requests from the modalities and handles requests from the reading workstations. Okay, the modalities would like to basically send the studies that they just got to basically archive them in the archive server, and the reading workstations basically need to basically grab some of the studies that were already placed in the archive server and basically download them in the reading workstation so that the doctors can actually start reading or start diagnosing the radiographs. Okay, so basically you're connected, or basically so many different computers or so many different systems are connected to that archive server. So basically, there is a risk that this loading might actually cripple that server. Basically, it becomes a little bit slow. Okay, so basically, you need to do something in order for you to be able to make sure that the response time for the archive server is reasonable and doesn't have any congestions. Okay, so basically, what you need to do is what's called load balancing, which means that you evenly distribute work across the network. So instead of having all the network devices, you have a server, and basically many clients are always asking things out of this server, okay? You might have more than one server, for example, okay? So basically what you need to have is, instead of just having one archive server, you have two, for example, or more, depending on the load, okay? And the request received can be allocated across multiple servers, multiple devices, or multiple servers, basically, okay, such as servers to balance loads, okay? And this is done in a way, usually this is done in a way that doesn't make any of the clients feel that it basically is connected to the first server or the second server. It doesn't know exactly which server he's connected to, this system is connected to. So basically, you're asking the server to do something. Basically, there is some kind of a load balancing, algorithm or load balancing system that would actually handle these requests and evenly distributes the load between the available servers. If you have two servers, then it would even the load between these two servers. If you have more than that, it would also work to even the load between the different servers. Okay, so to the user, this distribution is transparent, meaning that it appears that as if it's a single server providing the resources. So for example, let me give you an example that we all know. How many people use Google Drive? Is it just me, or many other people use that? I think many people in the world have Google Drive, and they use it. Basically, maybe it's hundreds of millions of people, maybe. Okay, whenever you're accessing Google Drive, is it just one server handling all the requests from all the users all over the world? It doesn't make sense, right? At the same time, when you're accessing Google Drive, you don't really know which, basically, there must be multiple servers, of course, but you really don't really know or even care about which server you're connected to. You basically feel that you have one server, and this one server is there all the time, and it's available for requests, whatever you want to do, it's available. So basically, this is exactly what we're talking about here. Okay? So whenever you do that, basically, you have the probability of overloading a single server is reduced. And each network computer can benefit from having optimized resources. So basically, instead of requiring your computer, for example, to have a lot of storage, you can have a central storage location, and basically you're still accessing that through the archive server without any problem. Okay, so you don't need to have basically a large storage you didn't really need to have the whole database from packs, for example, available to you or locally within your computer so that you can access it. You can access it through the archive server very effectively. And basically, whenever you do that, the network downtime can be also reduced, because basically the communication between the clients and the server, they are not connected to a single server, basically connected to multiple servers. So basically the traffic is now basically evenly distributed in the among the servers. So basically, you have a less probability of network downtime. Usually, the load balancing can be performed by software running on computer or as dedicated software devices. Basically, you can have a hardware that would do that for you, or you can have a computer that would receive these requests and basically handle the communication with the actual servers. So that it basically sends the servers, it knows, first of all, it knows which servers are available and knows basically which one is the address for each one of them, so that whenever a request comes, it can actually distribute the load among the available servers. Okay, the dedicated hardware server, if you have something, I think this is usually used in something like PACS. When you have a large hospital, you have a lot of MGIG modalities, you have a lot of reading workstations, it's actually much more effective if you have a hardware device to do that. Okay, so basically, if you have a hardware device, then this is basically, it's an embedded device. It doesn't have to be running on a computer. So basically, you can actually do that usually faster than a software running on a computer. But you have a hardware version, a software version of load balancing technology, basically. Okay. From the point of view of managing storage, several different technologies are available that can provide enhanced storage capabilities, such as storage virtualization, which hide the physical resources. For example, okay, let me also give you an example from common things that we all do. Okay, if you have a YouTube channel, okay, we have a YouTube channel for the program, which I actually all the presentations that I received so far were uploaded to that channel. Okay, so basically, my channel, basically each time I receive a video, sometimes videos can be like 1 GB. One of your presentations actually is almost 1 GB. Okay, some were a little bit less than that, like 20 or even less than that, 20 megabytes. But actually, if you think about how a YouTube channel would work, imagine how many people are uploading videos all the time. Okay, so basically, if you think that the web server for YouTube has a single storage location, then it's very easy to think that it's going to be filled out almost in a minute. Okay, each minute, basically, people upload huge amounts of videos. So basically, it would fill out very quickly, basically. But actually, this doesn't work like this. You have storage visualization. You basically, whenever you upload, you don't really know where you're storing the data. Okay, it has you're sending to YouTube, and within YouTube you have storage virtualization, have physical storage, and basically there is like a software, or basically this storage visualization takes care of storing the data in the proper physical device. You have many physical devices, and to the external viewer you see it as one. Okay, so basically you hide the physical resources from the user, and all storage devices are pooled meaning that you're adding them together. If you have, for example, 10 terabyte storages, like 100 of them, okay, basically you see them as 10 terabyte times 100 as a pooled, or basically you add all of them together, and basically this would act like a single hard drive of 1000 terabytes. Okay, and basically it appears like one large repository of storage. Okay, so basically this is very important as well. So load balancing is very important for servers, and also how to manage storage is also very important. This is also for our application. The PACS archive server needs managing storage this way, basically, because the huge amounts of images or studies that we actually store in the archive server would basically require that you increase the physical size of the memory all the time. So basically what you need to have is the capability of adding new storage, and this new storage will basically be seen as an extension to the existing storage. Okay, you don't have, basically you don't want to see it as a different drive or whatever. You have C, D, E, or F, and like you're probably going to run out of letters if you do that. Basically, you need to see like the C drive, for example, is expanding. Okay, whenever you add an external hard drive, like an additional new physical hard drive, it will basically appear as the existing drive was extended by this amount. And this is actually very convenient. And this is very important to have, actually. Now we're going to talk about protocols. Okay, so basically we're going to talk about how we communicate through the network. Basically, we're going to discuss a few examples of protocols that are of particular importance, but actually there are a lot of protocols, not just these. For example, if you're going to talk about, let's just talk about this, and then we can actually extend these to others, because we don't want to confuse you at the beginning. Okay, so computer networks have protocols or rules of communication. Protocols means rules of communication that are essential for proper communication to take place between network devices. So, for example, you have two computers connected to the same network. Okay, how can I send from one to the other? Okay, what's going to happen when I do that? Okay, how is that communication basically? How can I ensure that this communication will be reliable? Okay, how can I ensure that it's going to be secure? Okay, for example, when I send to a particular from a particular address to a particular address, how can I make sure that it will actually go to that particular address and basically make sure that it actually arrived there without any problems? Okay, so let's discuss things like that. Basically, the common protocols that we're going to talk about are things like TCP IP, which is basically transmission control protocol, internet protocol. This is basically the most important protocol in the internet, basically. And basically, we're going to see examples of this. These are very important. There are very important examples here. We're going to talk about wireless protocols. Basically, if you have a wireless router at home, and you have your laptop, and you're communicating through that router, through wireless communication, what are the wireless protocols that are available? And one example of what's called remote desktop protocol that would allow you through Windows to access another computer. For example, if you have a reading workstation, for example, this is actually unique to Windows, but actually it's a good example of things like that. So basically, if I'm working on Windows, I have another server somewhere in my network. Can I log in from my computer to that server and basically use my computer, my local computer, as this server, as if I'm sitting on that server? This is actually can be done with remote desktop protocol. So let's talk about the TCP IP. This is the most common protocol suite used today for local area networks as well as the internet. Okay, so basically this is very important. It's actually a combination of several protocols that function together, or basically you can consider them as protocol suite. So basically it's not just one protocol, it's a host of protocols. Okay, so the first or the two major protocols that make up its name, which are the transmission control protocol, the TCP, and the internet protocol, the IP. Okay, the IP protocol works at the OSI network layer 3, which is the network layer. Okay, this is basically the IP layer, and it's used to provide addressing and routing. Okay, so basically, if I wanted to reach google.com, I don't really know google.com. Basically, google.com basically it doesn't have an address there. Okay, it's basically it's like the basically the name address basically doesn't really give me an address, you know, through the internet that I can reach through the internet. If I wanted to get an address through the internet, I have to have an IP address. Okay, so how can I get that? Okay, whenever I get the IP address, I can actually, my router can start thinking about how to reach from one point to the other over the internet using that address. So basically, IP, or the internet protocol, is responsible for addressing packets and sending them on the correct route to the destination. Okay, so basically this works on layer 3. TCP is the main transport layer. Basically, it works on layer 4, basically, and it's responsible for establishing connections and reliable data transport between devices. So basically, this one here is responsible for the reliability of packet transmission. So for example, if the packet was transmitted incorrectly, there must be a way to detect that and basically request a retransmission so that whatever I'm sending over the internet reaches the destination in a correct way. Okay. So basically, if we want to talk about the where they are from the OSI model, we actually going to compare the OSI model to what's called the TCP IP model. Basically, the TCP IP, basically you have the IP here and the TCP is here. Okay, and basically these correspond to the layer 3 in the OSI model and layer 4 in the OSI model. From the point of view of the TCP IP, you don't really care about the hardware. You don't have a hardware layer, basically. The network interface here, which is the MAC address, basically the physical address of the device, of the networking device that you're using, okay? Basically, the internet considers the network interface as the lowest, basically, not the lowest, maybe this is the lowest level that it can get. Basically, it communicates only with the MAC. It doesn't know what's going to happen inside the networking card. So whatever the networking card is doing, from whenever I'm sending a message, you know how it's going to take it and send it as ones and zeros and things like that, it doesn't really care about that. So basically, it deals with a MAC address. So usually, for each MAC address, you assign it an IP, and that's it. You forget about the networking interface here and just start dealing with the IP address for everything else. Okay, so basically this is the kind of model that it uses, and basically it's practical because basically you don't really care about what's going to happen in the hardware. You don't really measure the the signals on the cables or wireless or whatever. If it's 1 or 0, you really don't care about that. You really care about the MAC address, and basically you care about the address, the IP address that was assigned to this device, and how the messages from this IP address can go, or basically how you're going to read, information from another IP address and bring it back to this IP address. So basically, the TCP IP architecture gives a framework for dozens of various protocols that comprise a suite, and also includes several high-level applications that are part of the TCP IP. For example, the DNS server, or the domain name system, okay, is a part of the TCP IP protocol. DHCP is also a part of the TCP IP protocol. FTP is also a part of this TCP IP protocol. Probably don't know much about this. We're going to discuss each one of them separately now. Okay, we're going to start with the domain name server. What is the domain name system? Basically, if you remember from last time when we did ipconfig, one of the items that we saw was the domain name server, or DNS. One of the information that we got was the DNS. Okay. So basically, the DNS is the way to resolve a particular address, a particular symbolic name, okay, to the IP address that is corresponding to it. So when I say google.com, this corresponds to a particular address, IP address. Basically, the domain name system or the domain name server would actually take the symbolic name and gives me back the address here, okay? Usually the same server can do a reverse lookup. So basically, if you have this, you can get that. I'm going to show you that. I tried that at. I made sure that it's working on the university computer, so we will be able to demonstrate that now together. Okay. So basically, you can imagine the domain name system as a database. Basically, you have, for example, www.xyz.com. It has address 128.150.11.2, for example, okay? And you have all the addresses and you have all the IP addresses for each one of them. So basically, I need to have that because the routing protocol would need the IP address. You need that to be able to route a message to or from a particular server, okay? So if I need to access google.com, I need to have the IP address of google.com. If I need to access microsoft.com, I need to have the IP address of microsoft.com, and so on, okay? So basically, if you imagine that you're going to have a table like this, that has all the addresses in the world of all the websites in the world, I think it's going to be a huge database, right? The problem with that is not just the size, it's how you're going to access that, okay? If I said, for example, google.com, okay? How I'm going to actually search that database and get the address for google.com and bring it back, okay? This is a huge problem. So basically, organize this database as a hierarchy. Basically, you have a tree, basically. It's a tree structure, okay? So that you can have a way of reducing the loading of the DNS system, basically. Instead of having a localized or a single DNS system that has all the addresses of every website, you have a hierarchy, okay? For example, you start with the extensionfirst.com, and then basically you have a high level, we're going to see that in an example. So basically you have for .com, and then you have the XYZ inside .com, and you have www inside XYZ inside.com, okay? So basically we're going to see an example of how this happens. And basically, at the end, basically you have the name of each site on the internet and its corresponding IP address. If a particular website, if a particular address, if a particular symbolic name of a website doesn't have a record in the DNS system with the IP address of it, it's not going to be, basically, you're not going to be able to access it. You're not, basically, it's going to come back to you and say that this doesn't have an IP address. We're going to try that together now, okay? So basically, storing the entire DNS database for the whole world in one location would present several problems. First of all, you have a bottleneck. Everybody, we were talking about the archive server. We were saying that we have a large hospital, and this large hospital maybe has 1,000 computers, for example, okay? Imagine that the DNS server basically is connected to all the computers in the world, all the computers that are accessing the internet in the world at this point would be connected to that single server. And this is a huge problem, okay? You have basically bottleneck, you have basically a potential to slow down the internet with all the users trying to access one copy of the database. And basically, if you have a single database and on a single computer, it's very difficult to handle multiple requests to that database. Basically, first of all, it's huge. So searching a huge database would take time. And basically, you have 1 billion requests basically every second. So basically, you have to queue all of them. You have to have them in line, and you finish the first and the second and the third and so on. So basically, it would really be a problem, and would basically definitely be the bottleneck that would determine the speed of the internet. You cannot basically have a fast internet with a situation like this. And another problem, if something happened to this one database, the entire internet would be basically affected. Basically, the whole internet would be down, basically, okay? So this doesn't make any sense, okay? So usually you have multiple servers, you have basically a hierarchy of the domain name system in general, so that you can access this very effectively, okay? So the DNS database is divided and distributed. So you divide it and distribute it to many different servers on the internet, each of which is responsible for different areas of the internet. For example, if I'm trying to access the google.com from Saudi Arabia, okay, am I going to access a global domain name server, or is there a local domain name server in Saudi Arabia so that I can access that? Usually you have something like, you have a local version of the DNS server, basically, so that you can access it and gain the information and basically use it to access or route your packages or packets, or route your information basically, to or from that address that you want to access, okay? Let's give an example on how the DNS lookup would look like in that divided and distributed database, okay? This is your computer, you're here, okay? This is you. You have a computer and you want to access the IP address of this address here, right there, okay? What are you going to do, okay? Usually you have a local DNS server. Actually, if you look at your router, you will find that you have one actually. Let's just go and see that. Maybe I can just demonstrate that first, and then we come back here. Okay, so basically I'm going to close that window and open a command prompt and basically show you that you have a local version of the domain name server. Okay. Okay, I didn't mean to do that. Okay, I actually need to have a window so that it can come up big. Okay, so as you see here, this is a command prompt from my computer. So basically, I'm going to try ipconfig, the same command that we used many times. Okay, so if you look at the output here, you have basically DNS server here. Okay, you have your IP address. You have the default gateway that we talked about last time. This is a router address. This is basically if I'm sending something to the internet, my computer is sending to this address. This is the local address inside King Abdulaziz University. Okay, and this is actually my IP address there. This is my address here. Okay, there is a DNS server address right there. If you look at that address, you'll find that 10, 13, 116, 30. If you compare that address to basically the default gateway, it's actually not the default, the DHCP server. We're going to talk about that. This seems like a local address. It's not, it's inside King Abdulaziz University probably. It's not outside King Abdulaziz University. So basically, what I access for the DNS is something that is basically either on the router or basically the internet service provider. And then through that, I can get to another DNS server. So usually this is a local server, basically. And this local server would be my hub, or basically, basically this DNS server would handle the other DNS servers in the world. So basically, you get the information one by one, and then bring you back the address that you need. Okay. So basically, this is a local server that is basically, this is what I see now, okay? Let's go back to the lecture and basically discuss a little bit more about how the process will go. So now this is my local DNS server. This is basically something local, something almost in the same network as my university, for example, if I'm working from the university, okay? So basically, I need to access that address. It doesn't have the address, it doesn't have the database here, but it will handle the query or the search for the IP address of that address that I requested. All it has actually is what's called the top level DNS server. It has the IP address of a server that would have the information about the COM server. Basically, we're going to divide that address into three parts. Basically, the part that has a COM, and then inside the COM, I'm going to have Nashville, and then www. Okay, so basically, the address is basically this part here. The last part of any address can be .com, can be .edu, can be .mil, .org, .whatever, okay? So basically, this address here would go to that server, and this server has all the last part of the symbolic address. It will have all the options for it right there. So for example, if my address ends with .com, then it would give you a domain name server for all .com addresses, okay? So basically, I'm asking here, what is the address of the COM server? Any questions? Any questions? Okay, okay, no problem. If you have a flight, that's fine. Don't worry about it. Okay, you can look at the lecture later. Okay, thank you. One of your colleagues will just send a message that he's leaving. Okay, that's fine. So basically, here I'm asking a question about basically what is the address of the COM server. The COM server is a DNS server that has basically all the options after the COM. But I need to reach that database first. So basically, I'm dividing the DNS to one for COM, one for ORG, one for .NET, and so on. So basically, all the addresses with .com are here. All the addresses with .org are here, and so on and so forth. So basically, here I'm asking about the server for the COM. So basically, here it would look up here the COM address is 10.35.83.77. So basically, it would send back the local DNS server this address right there. So now it's now one level done. Okay. Next, what is the address of Nashville.com? So basically, I'm within the COM server. I'm asking for the Nashville. Okay. So basically, I'm going to do that here. I'm asking about the, within the .com, I want the Nashville in particular. So basically, it would look it up and find it like there. So basically, it would send back this address right here. So this is for Nashville.com. Then I'm going to ask, what is the address? Basically, this is the address for Nashville.com and anything at the beginning. So basically, an address that ends with this, with anything here. Here can be multiple things. So basically, I ask, what is the address of www.nashville.com? So basically here, we look it up right there and get the address like this and send this address back to here. So basically, whenever I'm done with this, I have the address that my computer requested from the local DNS server. So it would basically, as you see here, it would just send it back to that computer, and this computer would start communicating with that address right away. Okay? Let's see an example of that, okay? So basically, there is a very nice command. I'm going to close that again and open the window for the command again. Okay, so this is a very nice command. Here it's actually available on Windows and Linux. So basically, it's called NS Lookup. Name server lookup. Okay, so basically, I can put here either the symbolic name or I can put the IP address. So basically, let's try, for example, google.com. Basically, here, as you see, the local DNS server basically is here, dnslb.kaau. You see here from the address that it's actually a local DNS server. So this will be actually the server that would handle the requests so that you can get the address at the end. Basically, you try that basically through that, and basically at the end you got the address for google.com right there. This is the address for google.com. There is another address here that we're going to discuss. This is what's called IP version 6. This is IP version 4. We're going to discuss actually the difference between these two, but these are equivalent. Okay, IP version 4 is the old version of IP addresses. IP version 6 is the new version, and basically we're going to say why we have two versions and which one is basically is the future, basically. Okay, so basically now you have a google.com and you got back the address. So basically I can probably try KAU. You have an address like this. Okay, 192, 168, 216, 233. If I try that in reverse, in Lookup, and I take that address here, 192.168.216.233, basically it will give you that information, basically, give you that same information. It actually came out like this, basically. The name would be like this. If you have a certain IP address, you can actually get the name, the symbolic name for it. through that. So basically, it works like a lookup and a reverse lookup. If you have the symbolic name, you can get the address, the IP address, and if you have the IP address, you can get the symbolic name. Okay. Okay. So let's talk about something that is actually. Let's see actually how the routing happens. Routing means that I have a certain IP address, and I would like to see how my computer would reach that that IP address. Okay. As I told you before, the internet is a network of routers. Basically, you're connecting routers together, and basically your information or whatever you're requesting or whenever you're communicating between two IP addresses, the information keeps hopping or basically keeps jumping between routers until it goes from the source to the destination. Okay, so there's one very interesting command here that would allow you to trace a communication between your computer or and a particular server to see exactly where actually, how you're going to reach from your computer to that server. This is actually going to be very useful when we're going to discuss, the part about troubleshooting. For example, if you have a problem accessing the internet, sometimes you actually try to access the internet from your computer and you don't know exactly why it's not working. Sometimes it's from the site that you're trying to access, it's not working, or sometimes it's from the internet that you have. So how would you know? How would you know that? Okay, there is a command here called traceroute. Traceroute would actually see the communication between your computer and a particular host. Okay, for example, let's see or let's track what the route between us here or my computer and google.com. Okay, so the command is trace RT. It's on I think it's on Linux, it's trace route. It's written as route, but actually on PCs, it's trace RT. Okay, so trace RT google.com. Let's see what's going to happen. First of all, it looks up the address for Google. Okay, as you see here, if you look at the address that we had before, actually it's exactly the same here. Okay, basically it's the same address that we got before for Google. So basically, it starts from something local. This is likely to be the local router. Basically, this is the gateway that we saw before. If I go up, this is the gateway address that we had. I'm sorry, it's keeps jumping. Where is that? I'm sorry, it keeps jumping, but actually this is the gateway address that I have. And then as you see, it starts hopping. Basically, these addresses seem to be local here, and basically starts after that start jumping outside. Okay, but actually this is the route. This is still routing the information from my computer to google.com. Sometimes there are some servers that won't respond, basically, that won't give that information. See here, this is something, like it's a JIDDA thing. It's not like a KEU thing. So basically, we're outside now. So basically, let's keep watching. As you see, a lot of steps just to get from, it's very simple, actually, when you say google.com and access it through the browser, you don't really think about these things. You don't really think about the information getting basically moved, between basic 18 servers or 18 routers here, basically. Okay, so basically there are 18 steps. Basically, it reached at the end here. The trace is complete because it reached the address for Google. Okay, as you see here, basically it's a Google address, but actually sometimes it's like a sub-server within Google. So basically, sometimes you end up with a strange name here, but it's the same IP address as google.com. So basically, it's one of the Google servers. Okay, you don't really, it's basically invisible to the regular user, but actually in a trace route, you can actually see where exactly it is. Okay, so basically here you can trace the package from your computer to the server of whatever website that you want. Okay, sometimes it's possible to do that. Sometimes it's not possible because some of the servers would actually deny a request to send information. So basically here you see how much time you spent on each one of the steps, through the way. So basically, if you have a local server or a local bottleneck, for example, internet bottleneck, that would basically delay the packets, it would actually look like it's very clear from the first steps here that it's much longer than it should be. Basically, the first steps here should be very quick, actually, less than 1 millisecond. But basically, when you go, to far away servers, sometimes it takes a little bit more. So basically, if you have a problem in one of the local servers, basically, you would end up basically having either the trace disconnect. Basically, it doesn't work. Basically, you don't reach the destination. Or you can actually see that you reach the destination, but with a very long delay. So you can actually use that to debug the connection that you have to a particular server. Okay, so trace router is one of the very important commands that you actually should know. Actually, it's very nice for debugging. And also the one that we used a little bit more, the NS lookup. This is very important to show you how the DNS server is working. Sometimes you have a connection to the internet, but you have a problem with the DNS server. If you have a problem with the local DNS server, this would be a problem, actually. Because basically, you're trying to translate the symbolic addresses to the IP addresses, and the DNS server doesn't allow you to do it. It doesn't give you an answer. Then, in this case, you basically, if you look at this here, you're probably gonna find that there is a problem here somewhere, and this problem basically would, first of all, if you try to get a trace route, you would not be able to get that address right there. So basically, it stops right there. Okay. So basically, let's try something that looks fictitious, basically. Google.com. Basically, here, the DNS gave me a message that unable to resolve target system name Google.com. Basically, it couldn't provide an answer. Okay, so basically, this is an example of a response from the DNS server to tell you that it doesn't have an address for that thing that you sent. Okay, if the DNS server is not working or working erratically, basically, it can actually it sometimes basically becomes unable to provide the address, and basically cannot basically provide the IP address, and basically whenever you don't have the IP address, the router cannot route. The routing happens basically based on the IP addresses, is not based on the symbolic addresses. So basically you need to have the IP address, and if you don't have that, basically you cannot do your function. So basically DNS servers are very important. They are basically invisible, basically you don't see them. But at the same time, any request that you do to the internet using a symbolic name, basically DNS is involved. Okay, if it's not working properly, you won't be able to access the internet. If, for example, if you remember from last time, when you configure, when you have a static configuration of a host, like basically we tried the automatic configuration, and basically when you do the automatic configuration, you get all the information like the gateway address and the DNS server address. If you're doing that yourself, you need to know the DNS server address. If you don't know that and you leave it blank, then you will have a problem. Your computer will not be able to access the internet because basically it doesn't have a domain name server, it doesn't have an address for the domain name server. So whenever you're trying to access a symbolic address, it will not be able to translate it to the IP address in order to route to that host. So basically, this is very important, and you have to take care of something like that whenever you do a static configuration for a particular computer. Any question? Okay. Let's go back to the lecture. So basically, DNS is very important. The other thing that we actually saw in the packet tracer simulations was what's called DHCP. This is an acronym for Dynamic Host Configuration Protocol. Dynamic means that it happens basically automatically. You don't really have to have a user basically doing anything for order for this to work. So basically, this is what is usually done if you have your laptop or mobile phone connected to your home network. For example, you have your wireless network, and basically, whenever you connect it, it assigns you an IP address and assigns you a gateway address and DNS server address automatically without you having to even think about them. Okay. Usually you don't really have to think about them, but actually for technical work, sometimes you need to do that. Okay, if you're going to connect, sometimes when you have multiple devices connected in a network, in a hospital network, for example, sometimes you need to know the IP addresses of different components or different devices so that you can have access levels, different access levels to each one of them. Some of the computers, for example, can be assigned to only view files locally. They are not capable of accessing the internet, for example. Okay, so that they can be a little bit more secure, for example. Okay, so basically you can't do that unless you have information about their IP addresses on the network. So basically, each device on a computer network must have a unique name or number. Basically, we're talking about the IP address, basically, Internet Protocol address. Because no two devices share the same name or number, packets can be transmitted through a network address to the device that has that unique identifier. So if you have unique names, which is very important, then if I say I want to go to 192.168.1.100, for example, there's only one device there. There are no two, you cannot get two devices with the same exact address. Otherwise, you get an IP conflict, what's called IP conflict. IP conflict means that two devices were assigned static IP addresses, and basically they have exactly the same address right there. This would be a problem for both devices. Okay, it's not like the first one that accessed the internet or connected to the network would work and the other one would not work. Actually, both will not work. Okay, usually both will have problems accessing the internet or accessing the network in general. Okay, so the uniqueness here is very important. So basically, if you're going to basically the computers on the TCP IP network, we're talking about a LAN, local area network, or a network that will be connected to the internet eventually. You will have logical addresses called IP addresses. And basically it's assigned to each host. Each host will have a different IP address. And the IP address basically is made up of 4 bytes. Or basically each byte is called octet. Okay, it means that it has 8 bits. Okay, it's, octal is like the number system that has 8 numbers, 0 to 7. Okay, hexadecimal is 16, for example. Decimal is 10. So basically, octet is coming from oct, OCT. Octal is like 8 bits or 8 in general. Okay, so basically, it has a total of if you have 8 bits times 4 bytes, it's gonna come up like 32 bits. Okay. And basically, what you usually do for these addresses is you basically list each two together as a number so that people can actually understand them a little bit more, okay? So each number, you address that number from 1 to 254, okay? And actually, you have a function for 0 and you have a function for 255, okay? We're not going to talk about them now, but actually, these are kind of reserved. One of them, for example, is used for if you want to send like a global cast. Basically, whenever we're sending from a particular address to a particular address, this is what we call a unicast. Cast like broadcasting, like we are sending information out. Okay, so unicast is going from one sender to one receiver. There is something called a global cast or a multicast, or basically basically it's something like you're sending to everyone. Okay, you can actually do that. You can select to do that here. Okay, we said that this is not a good thing, but actually sometimes you need it. So basically, if you, for example, you want to have a configuration sent to all the computers on the network, you actually use that. Okay, so basically these are reserved in general. So basically, you have addresses for each one of them for from 1 to 254. Okay, generally. Okay, and basically you indicate the numbers. Basically, you have the computer network and the host on that network, and basically you define the network or the subnet that you're using the subnet mask, as we discussed in the previous lecture. For example, if you have something that looks like this, and a subnet mask that looks like this, the 0 here would indicate that here can be anything. But these, the first 3 numbers, are basically must be the same for all the computers that are on the same subnet. Okay, so if you have a difference in these 3 numbers, basically you're going to have a different network. Basically, if you try to communicate as a local device, basically it's not going to work. Like we did last time. We tried to ping from one subnet to another subnet, one computer on one subnet to another computer on a different subnet. It didn't work. Okay, so basically this will define the local area or the local subnet so that you can actually have local communication between them. Okay, so basically in that particular example, the first 3 bytes or octet define the network, and the last one defines the host within that network. Okay, so basically this is kind of a way to basically divide the network over basically multiple subnets. Okay, as we said, we can have 2 ways of assigning the IP address. Okay, basically we mentioned that basically the example that we did before in Packet Tracer, we basically tried the DHCP and we got all the addresses automatically. So basically the DHCP basically automatically distributed the addresses automatically, and basically you just get the address and all the information that would allow you to access the internet, and this is very convenient. The static IP address, we said that it's not recommended, and it's recommended only for resources, not for hosts, not for computers. Okay, so basically here you have to assign everything manually. Okay, you have to put the address, IP address manually. You have to put the gateway address manually. You have to put the subnet mask manually. You have to actually put also the DNS server manually. Okay, if you have a network that has a large number of computers, then this can be really time consuming. Okay, and basically you can end up, usually actually you end up with IP conflicts. Okay, which is a big problem actually. Okay, so basically this is not recommended. If you're working in a hospital, then you really, let me put it this way, you really have to have a good reason in order for you to leave DHCP and use a static IP address. So basically you have to either have clear instructions from the manufacturer of the medical device that you're going to connect to the network, that you have to configure it in a static way. Okay, this is unique to that particular device, then you might want to do that. You can actually do that. But otherwise, if you have the choice, definitely go for the dynamic host configuration protocol, DHCP. Okay, so basically, whenever that computer is attached to the network, it sends a request, a global request, and this global request is received by the server, the DHCP server, and whenever it reaches that DHCP server, basically it gives it back an address and gives it back all the information that it requires to configure itself. Okay, sometimes the IP address is leased. Leased means that it's given to that host for a particular time, and basically if you disconnect and reconnect, it will give you the same address, but it depends basically, but it's not really as important. Okay, because sometimes it's actually most of the time the actual IP address you have is not really that important unless you have a reason, you have a resource on your computer that is accessible by other computers, then it really doesn't matter if you have for example here 100 or 101 or 102, doesn't matter. Okay, but actually usually you can actually configure the lease time. Lease time means that this particular IP address will be leased to that particular MAC address, okay, for the period of whatever, okay? And basically, if it keeps basically using that MAC address, basically it can actually keep working with the same IP address for that much time, okay? But this is not really that important. The important thing is to realize the difference between the static way of assigning IP addresses and the dynamic way. And I would recommend that all of you basically use DHCP unless you have a good reason, you know, for doing the static IP assignment. Okay. Do you have any questions? Okay. Inshallah, next lecture will be after the spring break. Okay, after the week off next week. And basically going to have the exam starting at 9:30, okay, as we agreed last time. Any change of mind about this? Any change of, any change you want to make to the starting time of the exam? Okay, so basically you're not going to have a lecture on the Sunday the 20th. There will be no lecture, okay? And basically you would just log into your Blackboard and basically you'll find the exam available exactly at 9:30. Be available at 9:30. Okay. The exam will close at 11. Okay. I will give you an hour and a half. Okay, to submit the exam. Okay. But actually the exam is intended for 1 hour. I'm just adding 30 minutes just in case somebody logged in a little bit late or something like that. If you have any problems from your internet connection or whatever, you need to contact me right away. Okay, you will find my contact information on Blackboard, and basically contact me by email or WhatsApp or whatever, so that I can tell you exactly. Basically, I can basically understand the problem you have and basically tell you what you can do to mitigate that problem. Basically, okay. Any question? Okay, have a good break, inshallah. Inshallah, I wish that all of you do well in the exam, inshallah. Shukran. Assalamu alaikum.
عليكم السلام ورحمة الله.